Hello, welcome back to Cracking the Cryptic. And a couple of days ago on Patreon, Simon put up his solution videos to the Lord of the Rings, the brilliant puzzle hunt by Blobs. That's 10 videos that you can watch, extra videos. If you are a $3 a month Patreon, I hope you give those a go. They're most amusing. Now, this month's puzzle hunt is a rather brilliant but very approachable hunt by Pause called a 6x6 Sudoku butt, and well, 9 of the 10 Sudokus are 6x6s, one is a 4x4, and they're all very approachable. Give them a try. You will learn something about Sudoku and you will learn something about your abilities, so check it out. Some people claim to have done it within an hour, but they're absolute experts. I don't. Do have a look at the Patreon though, and in a couple of days I think we've got a new treat for Patreons. Rockrat0, friend of the channel, has put together an amazing sort of samurai 5 interlinked Sudokus called 600k Bang. It's themed on the fact that this channel has somehow, nobody really knows how, reached 600,000 subscribers. So thank you very much to each and every one of you for letting us achieve that. We are very proud of it, even though you did all the subscribing. We just put out the videos. And that's what we're doing. We're putting out 2 Sudoku videos every day. We've also put out a number of apps which you can purchase if you follow the links under the video. We have Line Sudoku, our latest app, so that's relevant to today. Although we will also be looking at odd circles, extra regions, and that's about it. I'll do the rules of this puzzle in a minute. I do quickly want to mention our merchandise, like this fantastic water bottle, Cracking the Cryptic, knowledge bomb. If you're lucky, I'll favour you with one of those at some point. And perhaps you might be interested in Sven's Sudoku Pad, also on those links. Do check it out. First link, though, is to this puzzle, a debut for Brave Den. The puzzle is called Doggy Bag, and the original rules began with, what do you put in a doggy bag? Let's find out. Well, what has Brave Den put in his doggy bag in terms of the rules? Let's discover that. So normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Coloured areas contain no repeat digits. So here's one of those areas. You'll notice there are 2 blue coloured areas. That's one of them. That's the other. There's a green over here. I don't think the colourblind ought to have difficulties with this, but you'll let me know if they do. We may be able to produce a different version. Red is there, yellow is there. So each coloured area has no repeat digits in it. So since they're all 9 cells big, they are set to the digits 1 to 9. Along a green line, neighbouring digits cannot be within 5 of each other. They always have a difference of at least 5. So these could be 1 and 9 or 1 and 6, but not 3 and 7. Along an orange line, this is a Dutch whisper line, neighbouring digits have a difference of at least 4. And a grey circle indicates an odd digit. There are 9 of them in the puzzle. Give it a try on the first link under the video. I'm going to give it a go now. Let's get cracking. So, we've got all these extra regions. Okay, I think this puzzle is an introduction to basic set theory. And it might be very useful as that. So, in set theory, set stands for set equivalence theory, rather tautologically. And in set theory, we compare one area against another area, knowing that they contain exactly the same components, and then eliminating common components. So it's very straightforward, actually, to compare box 1, which we know contains the digits 1 to 9 by the rules of Sudoku, versus the orange area, which we know contains the digits 1 to 9 by the rules of the puzzle. And if we eliminate the common parts, which are those, we see that those 2 cells remain in box 1, and those 2 cells remain in the orange area, and therefore these digits must be the same. Those 2 must be the same digits as these 2, because imagine they were 1 and 2. These would be the set of 3, 4, 5, 6, 7, 8, 9, which would only leave 1 and 2 over in the box or in the area. So these two are the same as these two, and we can go a little bit further. This digit can't be the same as this one, so this digit is the same as this one. And therefore this digit is the same as this one, and given that it's a given 1, we can put in a 1 there. Now, try the same with this blue area. Just pause the video and see if you can see exactly what to do. It is exactly the same principle. In fact, it's mirror symmetric. But those two digits have to be the same as those two. That one clearly isn't that one, so it is that one. And this one is therefore this one, and they are 2s. Now, we have the same shapes in yellow and purple down at the bottom. So those digits are the same. Actually, I should probably mark them as odd. I can't really use orange colouring. So let's put the pen tool on, and since that is odd, that must be odd, because they're equivalent. The same was true up here. That one and that one are the same. Oh, I don't know that that's odd, so I can't mark those two, although those two cells are the same. But I can for this one, because it's got a circle here. Anyway, we need a 4 there, and this is slightly different. The given digit is in the other one of the pair. If you look at those pairs, the given digit's always on the inside, but in this pair it's on the outside of the central box. So that is the digit there, and this digit goes there. Now, the greens have a slightly different, green and blue areas, or this blue area, have a slightly different set theory extra digit, but it's obviously very simple. If you eliminate those 8, green has that cell and box 6 has that cell. So these have to be the same. And that's odd as well, because this one is, and that digit is the same as that. Okay, I haven't really done enough. I'm going to put on the pen tool as well, the letter tool I mean, so that I can label these as digit A, because they have to be the same. We've worked that out. These can be digit B. They have to be the same as each other in blue versus box 4. C proves yellow versus box 7. D proves purple versus box 9. E have to be the same according to green versus box 6. And F according to blue versus box 3. Now, I just have to warn us and myself to be a little bit careful, because these could be, in some instances, the same digit. B doesn't, I was going to say B doesn't, yeah, B could be the same as F, for instance. There's nothing to stop those 4 digits in the puzzle being the same digit. There aren't many places where equivalences are possible. A could be the same as either E or D, obviously not both. So we just need to be a little careful. I mean, A equals A, that's definitely true, and B equals B, but B could equal F, and there are other similar equivalences. Anyway, worth noting. Now, the orange whisper line is actually probably very helpful. 4 can only sit next to 8 or 9 on such a line, and then this is going to be low. Low O. Well, I mean, it sees 1, 2, and 4 in the box. So it has to be at least 4 away from that digit. Now, you could write 3 and 5 in there, because 9 could sit next to 5. But then you notice this is on a green line. And one of the things we know about German whisper green lines is you can never put 5 on them. So D is a 3, and we've actually got it. And that's another odd digit. This is now at least 5 away from 3, and it's not allowed to be 8. So it's 9. And these two we're given as odd. Now, I told you, and I stick by it, you can't put 5 on a German whisper line. It has no neighbour that it can sit next to. And there is a German whisper connecting all of these 3. So the digits here, which can't be 5 or 3 or 9, are 1 and 7. And we know the order from the German whisper rule. So they've gone straight in. C is another odd digit. And in this row, C sees 9 and 3. In this row, it sees 1. So C is 5 or 7. We've completed this whole whisper line. Right, this whisper line might be useful next. This digit is at least 5 away from 2, so that's 7 or 8. We know it can't be 9 by Sudoku. This is now low and can't be 1 or 2. I think that's going to have to be 3. Yes, I'm thinking slightly in Dutch whisper terms, and I was wondering, could that be 4 next to 8? But this is a green line, a German whisper line. So that's 8, and now that's 9. And the 2 4-cell whisper lines are fully done instantly. Now, this digit, A, sees 1 and 3. So it sees 1 in row 3 and 3 in row 2. So it's 5, 7, or 9. E is odd as well and sees 3, 7, and 9 in this column and 1 in this box. So E must be a 5. Now, the one box, the one coloured area I didn't do a comparison is red, and it's timely to look at that now. If you compare red with box 8, those 2 cells are the ones that are not in those 7, and those 2 cells are the ones that are not in these 7. So these 2 must be exact equivalences of these 2, and this is how our basic set theory is working. So that digit is going to have to be there. That is basically C now. And since it can't be 5, it's going to have to be 7 in all of these positions. And this one is the same as that one, so that's 8. And this orange line works. Now B and this other digit are 6 and 9. So B has to be 6 or 9. Gives us a pair in row 4 that I can't use. A can't be 7 anymore because in the columns it sees that. Now we're going to have to use the other little green lines and the few remaining odd digits, I think. This digit sees 1 and 7 in the column, 9 in the row, and has to be odd. That is 3 or 5. This one sees 1 and 3. This one sees 3 and 7. But it's on a green line, so it can't be 5. That's an extreme digit, 1 or 9. F is in those 2 positions. Can't be 1, 2, 8, 3, 9, 5, or 7. F is 4 or 6 by elimination. Remember, F could be the same as B. They could all be 6s. 9, 1, 3, 8, 7. We need an 8 in column 8, and it can't be on the odd circle, so it's got to go there. Yeah, I think we need to do more Sudoku now. That's the stage of the puzzle we've got to. Oh, we need a 5 in row 4, and I can use the green line. You can never put 5 on the green line, so it's got to be there. Then we have 3, 4, and 7 still to place in the row. That one is a naked 4. That makes F into 6 and leaves a 3, 7 pair in the row. This is odd and sees 1 and 3 in the column, 5 and 7 in the row. That's 9. It's going to finish off the central box. Turns out B and F were the same. They were 6s everywhere. This digit is, if it's going with a 3 on the green line, it must be an 8. If it's going with the 7, it's 1 or 2. 8, 9, 4, 5. This is a 1 to complete the final column. So that's not a 1. 4, 1, 5, 9, 8. We've got 6, 2, 3, and 7 to place here. I don't know the order. 9 is looking at that cell. That's a 1. This is high, and it's not 6 or 7, so it's 8 or 9. Oh, look, I still haven't resolved A. Interesting. I didn't know that was left over. Now, if this was high, it could only be 6. Oh, if this was high, it could only be 9. I don't know. Right, this one can't be high at all. It sees 7, 8, and 9 in the row. And if it was 6, this digit would have to be a 1, which it can't be. So this is definitely low. It sees 4 and 3, so it's 1 or 2. This is now high, and this digit is seeing 7 and 8. So this is 6 or 9. If it's 6, that's definitely a 1. 8, I don't know. 1, 6, 4, 7. There must be some straightforward Sudoku. I can place 1 in box 3. That's there. Then 1 in column 6 is here. And this is now high and can't be 8, 7 or 9. So that is a 6. One of these two is a 6. 1, 7, 8, 6. I feel like I can do something else in box 8, but I can't see what it is. These digits have to include 1 and 9 in this row. So the 1 is in one of those cells, the 9 somewhere in the row. 1, 6, 4, 7, 5 can't be there. So 5's in one of these two. And then this has become a 5, 6 pair as a result of that. This is now a 2, 4 pair. Let's look along this bottom row. 7, 2, 4, 1, 6. So these are from 3, 5, 8, 9. Okay, the only thing I can see that is helping me with is it keeps 2 out of the corner. And in the top, in column 1, in column 1, 2 must now be in one of those cells. And that resolves this. If it's been pencil marked correctly, can't be 2 anymore, must be an 8. On the whisper, that's a 3. This is a 7. That's a 3. And the puzzle's getting better. It's getting done more now. Now, in this row, we've got 1, 7, 9 here, but 1 and 7 have to be a pair in these cells. So that's 9. That fixes 2. This is 4. In this column, 9 has made A into 5. That was our last lettered digit. We get a 3 in the corner. That's 3 in the corner. That's 3 in the spotlight. Now, in the bottom row, we've got 3 and 9 to place here. I don't know the order, surprisingly. I still don't know how to disambiguate this. How about this row? 3, 4, 7, 9. The 9 has to be in one of these two cells because of these two 9s in the grid. And then this circle becomes a 7. That fixes 1 and 7. That puts this as a 2. And on the whisper, that stops this being a 6. It makes it a 9. That fixes 3 and 9 down here. This is a 6, 1 pair. 9, 8, 2 up here. We can fill in the 9, and that's a 2, 8 pair. This has been a good primer in terms of basic set theory. Of value in that respect. This is a 5, 4 pair. I don't think I can fix all of these until I get something in the rows that are looking at them. And here it is. This is 5 or 6 according to the row, and we've got a 6 in box 8. So that's a 5. Now I can unwind all these pairs in columns 7 and 8. And that 5, 4 pair may inform things. Oh, I could have got the 5 anyway. 5, 7, 1, 4, 3, 8, 6 above. 9, 8, 2. That's an 8. This is 7, 4, 2. And then we've got a 2, 3, and 4 to put in, and I think we are done. There we go. So not too tough. Nice puzzle. Doggy bag. That's what we get in the doggy bag. We get a bit of set theory and a few crunchy bones to get going with. It's a nice puzzle and fairly approachable, which is always pleasant. Let's get rid of the circles now. It's just me introducing elements into the grid. There we go. That is Doggy Bag by Brave Dent. Hope you had a good go at it and enjoyed it. Thanks for watching. Bye for now.